Friends, at the beginning of this chapter, let us now first see what is the meaning of the term element itself, because in this entire chapter we will be talking about the elements. So let us first see what is the meaning of the term element. Now, elements are different substances which are present in its isolated pure form or uncombined form. Like say for example, if in case we talk about hydrogen. Now this hydrogen is an element. Now hydrogen is an element. In a similar way, we can have helium as an element. In a similar way, we can have lithium, beryllium, boron, carbon, nitrogen, oxygen. All these, therefore, means all these different types of substances which are present in its isolated individual form. It means it is present in an uncombined form. It means it is not combined with any other element. Sir, what do you mean by combination with any other element? What I basically mean is that this hydrogen element can very easily combine with another element, like say for example chlorine. It can easily combine with chlorine and hence forming hydrogen chloride gas or hydrochloric acid, as we already know. Now in this situation, when hydrogen combines with chlorine, in that case it forms a molecule. So what is a molecule? Molecule is nothing but a group of atoms wherein more than one atom is present. Now in the case of molecule, it can be of two types, wherein we can have a group of atoms, that is more than one atom combined, which are bonded to each other with the help of a chemical bond, wherein we can have a group of atoms wherein the different atoms which are involved in the chemical bond can be of the same element or they can be of different elements. So in the case of this particular molecule, we have two hydrogen atoms which are chemically covalently bonded to each other, and this situation will be different from, this is a situation which will be different from the situation in the case of HCl. In the case of HCl, we have two different elements. Chlorine is one element, hydrogen is one element. That way we have total 118 elements in the periodic table. So in this specific case, both the atoms belong to hydrogen, right? So here we have one atom of hydrogen element which is chemically bonded with one atom of hydrogen element. So both these atoms belong to the hydrogen element. Here this atom belongs to hydrogen element, this atom belongs to chlorine element. So that way different elements, atoms of different elements, they can combine together to form molecules. Again, as I have told you, molecules can be of two types, wherein it can be a situation wherein it can the molecules contain atoms of the same element or they can contain atoms of different elements. So what are elements? Elements are basically such substances wherein if in case you break them down, you won't be finding different type of substances which will be present, in which one substance, if it is broken down, it will not form any two or three different types of substances. It will form the same substance itself. So if in case you break the hydrogen molecule, the result of that will be hydrogen atoms, which will be again be the same element as hydrogen. So therefore, whenever you break a substance in elemental form, if in case you break it, the resultant parts that you get will also be of the same element. Now, such a situation wherein we have a molecule in which more than one element is present, such a type of these are basically called as compounds. So compounds basically contain molecules in which there are more than one elements atom which are chemically bonded to each other. So hydrogen chloride, the name of hydrogen chloride is a compound. Sulfuric acid is a compound, but in that compound we can have n number of molecules which is present. We can have one molecule of a compound, one molecule of hydrogen chloride compound, we can have two molecules, we can have 5 molecules, we can have 10 molecules, we can have 100 molecules, we can have thousands, lakhs, crores of molecules of the compound. So that compound is the name of that particular substance, right? And that compounds, you can take how many number of molecules, as many number of molecules as you want. So this is, my dear friend, the difference between an element, a molecule, and a compound. So this is basically the fundamental of this chapter, which you will be basically be needing in this chapter of periodic table. So in this chapter from now onwards, we will be looking at how the different elements, individual different elements, which cannot be further be broken down, these individual different elements which can be arranged in terms of their properties. So in total, we will be, as I have already told you, we will be having 118 elements which will be arranged in terms of their similarity of properties. Hi friends, welcome to this chapter of periodic table, which is also called as periodicity of elements, different ways of calling the same thing. So let us now look at what we are going to do here. As the name suggests, obviously we are going to here study the periodic table, the modern periodic table. However, before coming to the structure of the modern periodic table and trying to find out the different similarities between elements, right now we will be starting with the basic need for a periodic table. Why did we basically need a periodic table? What was the need for creating a periodic table? So we are going to start from that point, and after that we will be looking at all the different attempts which were made by different scientists leading to the formation of the modern periodic table. Now you guys know that everything has to be perfected, right? Means we do not get the latest version of anything directly. We need to continuously keep on updating it, keep on improving something, and only after that we get the latest concept. Like say for example, if in case you have got Android 6.0, so Android 6.0 didn't come directly like this. We earlier had Android 1, then Android 2, then Android 3, Android 4. That way we had different types of Android. And after that, finally, right now, we have the latest version of Android. So I hope so you're getting the point. So in a similar way, we didn't directly get the modern periodic table. We got many different theories on the periodicity of elements before we got the modern periodic table. And each scientist who gave his theory on the periodic table used the concept of the other scientist who had given his theory beforehand. So every scientist was basically standing on the shoulders of the scientists before him to give even better theory on the periodic table. So once we understand that concept, we now need to understand what is the need for a periodic table in the first place. Why do we need a periodic table? Now let us see. If in case, say for example, we have got 50,000 books in a very big library. So is it okay if in case we keep all the books or related to all different subjects, related to all different authors, related to all different dates, in the sense recent books and old books. If in case we keep all the books randomly in all the different shelves which are present in the library, will it make any sense? If in case you want to read a particular book, like say for example Resnick and Halliday, you basically will need to search all 50,000 books to get to that specific book. So if in case you are lucky enough, you might find it initially. If in case you are not lucky, in that case you will have to find out literally around 50,000 books before you find your the book that you are looking out for. So which basically doesn't make any sense. We want to save our time, right? We don't want to waste our time doing unnecessary searching for the book that you want. That is the reason why, my dear friends, what's actually done in libraries to prevent this exact situation is that books are classified on the basis of the points which I have already made to you right now. Books are classified first of all on the basis of subjects. So the books of one particular subject, like say for example chemistry, all the books are kept in a particular section wherein you will be having different shelves wherein the books are kept. Once the books are classified on the basis of subjects, then in a particular subject there are still subcategories. Like say for in the case of chemistry, you will have books related to physical chemistry, then analytical chemistry, then inorganic chemistry, and finally organic chemistry. So there will be some shells which will contain books of physical chemistry, some shells having books of analytical chemistry, and so on. So once we come to physical chemistry, again there will be the physical chemistry books will be arranged in terms of the date on which they were published. So the oldest books will be lying at one part, and starting from the oldest to the latest books, the different books will be or can be arranged. So with this, if in case you want to search, it will be very easier for you to search. Or on the other way, or the other way will be to keep the books in terms of the alphabetical order of the authors, with which it will be very easier for you to find out. So if in case you are finding out a book for Resnick and Halliday, for example, in that case you will go to that specific subject's bookshelves, and there you will be starting to find out the shelf where the books having the author's name starting with R are kept, and it will be very easier for you to search it very quickly. So I hope so, my dear friends, you are getting the entire point of what I am trying to tell you. There are in total more than 118 elements which are present. Now all those elements have to be arranged together at one place in such a way that it makes sense, in such a way that all the elements having similar properties are arranged together, and all the elements having properties very much dissimilar to these set of elements has to be kept as much far away as possible to these set of elements. So we will be having again elements which have a property similar to the elements on the left hand side and the elements on the right hand side. Both of these elements on the extreme left and extreme right, they are exactly opposite to each other in their properties. Then the elements will be there in the middle, will be having having properties similar to both the elements on the left hand side as well as right hand side. So I hope so, my dear friends, now you have understood why and what is the need for the formation of a periodic table wherein the elements are systematically arranged to get the similarity in terms of similarity of properties of elements. And right now we will be looking at the first attempt which was made by a German scientist whose name was Doberener. Please don't mispronounce it as Doberman, which is different. So here we have Doberener's law of triads. Now this scientist called as Doberener, in Germany, he had given his first theory on the law of triads. What he said was that what he did was that he arranged all the elements in the increasing order of atomic weights. Once he had done that, in that case, he took three similar elements, the elements which are very much similar to each other in terms of their physical and chemical properties. And those three elements, he had taken an average of the atomic weights of the first element and the third element, and he came to a conclusion that the average of the atomic weights of the first and third element of the triad will be approximately or exactly equal to the atomic weight of the middle element of the triad. So let us quickly look at some of the examples which Doberener had considered while giving his theory on triads. The first example that we will be considering will be those of alkali metals. Now we know that in the case of alkali metals, we have the first example as sodium. The next example of alkali metal which is present below sodium in the periodic table, that is potassium, and after potassium we have an element which is okay, we can consider lithium here before sodium. I think that will be better in terms of calculation. So let us write down the atomic weights of all the three of them. So he arranged the elements in terms of increasing atomic weights. So in the case of lithium, the atomic weight of the atomic number of lithium is equal to 3. Hence, its atomic weight is equal to 7. In the case of sodium, its atomic number is equal to 11, its atomic weight is equal to 23. In the case of potassium, its atomic number is equal to 19, its atomic weight is equal to 39. So let us see if in case it holds true in this specific case. So here, if in case we take an average of the atomic weight of the first and third element, let's see what we get. So the average is equal to 7 plus 39 divided by 2, right? Because there are two elements, so the average will be considering 2. So therefore here we will be having 39 plus 7, which will be equal to 46, which will be divided by 2, right? So therefore here we will be getting the final value as equal to 23. So therefore here the average of the atomic weights of the first element and the last element, the average is equal to 23, which is exactly equal to the atomic weight of the middle element. Dobiner had also given a few more examples. Let us consider a few more examples in this. The next example that he had considered was between the elements of the other extreme, wherein he had considered the elements of halogens, in which we had chlorine, and then we had bromine, and then we had iodine. In the case of chlorine, we already know that the atomic weight of chlorine is equal to 35.5. The atomic weight in the case of bromine is equal to 80. The atomic weight of iodine is equal to 127. So let us see what happens to the average in this specific case. If Doberner's law of triads, that whether it holds true or not. So here we have this is the first element, this is the third element. As you can see, the elements have been arranged in the increasing order of the atomic weights. This is the least atomic weight, medium atomic weight, the largest atomic weight. So here let us consider the average of the atomic weights of the first and third element. So here again, if in case we find out the average here will be equal to 35.5 plus 127 divided by 80. And let us see what we get. Here we get 35.5 plus 127. We need to actually do the total. So here it will be finishing with 0.5. Then here we have total of 7 plus 5, which is equal to 12, right? So here we have 2 plus 1, which is 3, plus 3, which is 6, and then we have 1. So we have a total of 162 divided by 2, not divided by 80. 80 is the atomic weight of the second element, so it will be average, therefore divided by 2. And if in case we divide it by 2, let us see how much we get it. We get the answer as 81.25. The atomic weight of the middle element is 80, which is not exactly, but at least approximately equal to the average of the atomic weights of the first and third element of the triad. So for the second time, we have now proved that Doberner's law of triad had proven successful. Let us consider a final and third example for the same, and let us see if in case we get the correct values for the same. So in this case, the third example that we can take will be that of alkaline earth metals, wherein we consider calcium as one of the elements, then we can consider barium, and then we can consider strontium. So the first element in this triad will be calcium, having an atomic weight as equal to 40. Second element of this triad will be strontium, having an atomic weight of 88. And third element here will be barium, which will be having an atomic weight is equal to 137. So as you can see, again the elements have been or having similar properties have been arranged in terms of their increasing atomic weight. So therefore, if in case we want to find out the average will be equal to 40 plus 137 divided by 2, which will be equal to 177 divided by 2, which will be equal to 80. To 8 is 16, and then again 2 8 is 16. So again we will be having 1, so it will be 88.5. So here we got the value as equal to 88.5. As you can see, my dear friends, here the value is very much similar to the second element, wherein the atomic weight of the second element is equal to 88, which is very similar to the average of the atomic weights of the first and third element, wherein all the three elements are very similar in their properties because all of them have +2 oxidation state. Here all of them had +1 oxidation state, here all of them had -1 oxidation state. So these were alkali metals, these are alkaline earth metals, and these are halogens. So what was Daubenar's law of triads in terms of statement? When Daubenar arranged elements having similar physical and chemical properties in terms of increasing atomic weights, and he formed a triad out of them. That is, a triad means a group of 3 elements out of them. He found out that the atomic weight, the average of the atomic weight of the first and third element of the triad was exactly or approximately equal to the atomic weight of the second element of the triad. So this was, my dear friends, related to Daubenar's law of triads, and we had started this chapter with the understanding of why exactly we need a periodic table.